So for today, I'd like to do two things. So if we have time and if you have the computer for that, and if you are motivated to do so, I will explain you a little bit how colored coin work at the protocol level. So it's a pretty much technical presentation. Okay, so I will be a little bit into the technical aspect, and I will also show you how we can implement what we call Ricardian contract on the Coroid coin protocol. A Ricardian contract, very broadly said, but I will come back on that after that, is a contract that can be written by a computer or a human that is signed by someone that needs to respect the contract. And if the contract is violated, a software can detect it automatically. Okay, so we will see it's not so much a smart contract exactly. I will call it a dumb contract, but it replicates. We will see that it can replicate some of the feature of a smart contract. Okay, so first of all, the Coroid coin protocol that I'm using is called Open Assets. There is other protocol. Nasdaq will be using Open Assets. So the Ricardian contract aspect, it's very theoretical. For now, it's not used. I just present the principle and how to do it technically. But for now, nothing use it right now. Okay, so it's very much a theoretical aspect. So once we have done that, I think we will just try to act together some code. So if you are using Mac, you will be able to use MonoDevelop or Xamarin Studio, whatever. If you are on Windows, you will be able to use Visual Studio Community Editions. And we'll see how we can act together some line of code so you can make your own transaction, emit your own coin, all by code without any third party. So the goal will be you connect directly to the network, you do your transaction, you sign it with your key, and you send it to the network. So it's basically a kind of Hello World in colored coin. So I try to do that. We'll see if we can go on to the end. And before starting that, I will explain the theoretical aspects of colored coin. Okay. So just to know, who know deeply about the technical aspect of Bitcoin? I mean, for example, who know what is a script SIG? A script pub key, for example. Yeah, two? Okay. So I will just explain a little bit how Bitcoin works in the detail, because not everyone are familiar with the deep technical aspect. Bitcoin is very simple. The principles are very simple, so it will be kind of easy to do. So in the Bitcoin network, I will show you how Bitcoin are transferred. Once you understand that, I will show you how colored coin are transferred, and once I will have show you that, I will show you how we can implement a Ricardian contract. Okay, I try to do all of that without losing you. I try to do so. If you start having problem understanding what I say, just stop me. Okay, there is no problem. Most of the time, people don't want to raise their hand, but if someone has a question, most likely someone else will have. So prefer you tell me if there is a problem. So first of all, a Bitcoin transaction is separated into two parts. I will use this convention to say the top part is called the input, and the bottom part is called the output. Okay? So I will use this convention to represent a transaction. And so the input is what coin will be spent. So here you will want to spend some coin. Okay, and the output port is where your coin will go. So, for example, you will say, okay, I want four of them to be sent to Alice, and I want, I don't know, four other, for example, to send back to me. Okay, that's basically how a Bitcoin transaction works. You choose the coin you want to spend, and then you create new coin. So, for example, here there is 2 coins, and their value is 4 and 4. Okay, so basically this input just reference a coin of another previous transaction. Okay, so for example, if this transaction passed, then you can do another one and say, okay, I want to spend this one, so it's 4, and I want to send, for example, 2 to Bob, 2 to Alice. Okay, so for example, this one. This is how the system works. Okay, so in this case, the first transaction send money to Alice. Okay, and Alice now decide to spend it, and then send 2 to herself and 2 to Bob. So here, basically, Alice paid Bob 2. Okay, understood? Okay, so in technical term, in technical terms, the destination, for example, me or Alice, in technical term, we call that a script pubkey. It's the destination of the coin. Okay. So this is a script pubkey. What defines your identity on the blockchain is what we call an address, for example, on the blockchain. Ultimately, it's a script pubkey. It's the destination of the coins. Okay, so most of people that use Bitcoin every day are familiar with the concept of address, right? But when you code into Bitcoin, you don't talk about address, you talk about script pubkey. Because address is a particular template of script pubkey, but this script pubkey is a kind of contract. It's a script, and you can have lots of different scripts that can be created. Okay, so an address is one of these scripts, but at the core of the protocol, there is no such thing as an address. There is only script pubkey. Okay, so then when Alice want to spend, she need to prove to the world that she are the owner of the script pubkey. Okay, and so she does that by sending what we call a script sig. So in the case, for example, of an address, the script pubkey is a public key, and the script sig is a cryptographic signature proving that Alice own the pubkey. Okay. Yes. It's a way of proving that you own the script pubkey. In fact, you can see script pubkey like a challenge. No, script sig, the public key is what we call the script pubkey. In fact, is a challenge that you need to resolve in order to reclaim the coins.
The name comes from originally when it was designed. The script it was first designed.
Yes.
You have a public key, and you have to provide a signature that you have to provide the key. That was the original simplest thing. Put a public key there. When you send, you have to be able to. then when you in your script sig, your signature, a signature. So that's the simplest one.
Yes.
Is script public key is a public key, and script sig is a signature. But you can also do all kinds of more sophisticated things with script.
Yeah, for
And
example,
it still has the same stupid name.
yes, for example, I can very well create a script pub key that says the following thing, that say, if someone know my birth date, then he can spend this key. He can spend this coin. Okay? So before it was really a public key. Nowadays it's a script, and the script most of the time it's a public key, but it can be anything in reality. Okay? The only thing that you need to understand is that script pub key is a challenge that you need to satisfy to spend the coin, and the script sig is a response to this challenge. Okay? And there is a language for these two scripts. So we'll see briefly how it works, because we'll need it for the Ricardian contract. But that is basically it. Okay? So script pub key, script sig. The concept is clear. Okay? The challenge, how you resolve the challenge. The challenge, the response. Which one? So no, because a private key you can't show it to the world. Everybody see your script sig. So it's a signature. It's not a private key. It's a signature. Okay. Most of the time it's a real cryptographic signature, but it can be something else that just resolves the challenge of that. You'll see, for example, we can make an arbitrary challenge where if you find the passcode, if you find some passcode, then you will be, if you guess, for example, my birth date, you can spend it. We can make something like that. It's possible. So the script pub key can be a multisig. Okay, it can be a signature, a normal address, whatever. It can be a lot of things, and we can see how we can use that for enforcing Ricardian contract later on. Okay, so this is the basic principle of Bitcoin. Okay, so where does the colored coin fit? In this example, you see the 4 here. We can say, okay, it's bitcoins. Okay, it's 4 bitcoins that is transferred to Bob. 2 bitcoins has been transferred to Bob, for example. Okay, but the principle of colored coin is that instead of sending bitcoins, you will send tokens. For example, 2 USD, for example, to, I don't know, Alice. Okay, so this coin will not be real bitcoins. It will be some arbitrary token that you can transfer to each other. Okay, this token, to create it, the creation of such token at the first place, we call it an issuance. Okay, so you can do your own token. We'll try to do it in code later on, and once you have done that, then you can transfer it to someone else. So people that get it can retransfer it with someone else. They can trade it on an exchange or whatever. You can do what we want. But first, I will explain how to issue that in the first place with the Open Asset Protocol. Okay, I will try to explain a little bit the technical details behind the Open Asset Protocol. So the nice thing about Open Asset is that the protocol is kind of simple. The implementation is something like 300 lines of code, so it's basically simple, and I can explain it in one talk, which is maybe not the case for more important thing like like how do you call that? Counterparty. Counterparty is another Coin protocol, but you can't trade Bitcoin against another token. Whereas in OpenAsset, you can trade one USD against one Bitcoin if you want. So we'll see how that works. So this is good for that. Okay. So now I will explain you how to issue a coin. So issuing. So before trading a token, you need to issue it. Okay, so the thing that OpenAsset protocol solve is how can we prevent someone from spoofing a coin. For example, imagine that the Fed, for example, emits his own coin on the blockchain, for example, 5 USD. How does the blockchain ensure that when you receive this coin, then it has not been spoofed by someone else that tried to emit it? Okay. So what happened is that, so I will make a first transaction. Okay. So imagine that I am the Fed, okay, the central bank. So if I want to emit a coin, it's very simple. Imagine that I have, for example, 100 Bitcoin. Okay, so which belong to the Fed. Okay. If the Fed want to issue one Bitcoin, here is how it works with the OpenAsset protocol. In fact, it's very simple. What will happen is that, so for example, let's say this is let's add for example, yeah, one Bitcoin. So what the Fed will do is to spend this 100 BTC. Okay, so they spend it, and from the Bitcoin point of view, they will create an output that whose value is 0.001, something that doesn't have a very low value of Bitcoin. Okay, and they will send it, for example, to Alice. So where the OpenAsset protocol kick in is where in the output you can for those who know, you can add arbitrary information inside the transaction. We call that the op return script sig. So it's a way to attach some arbitrary information into a transaction. Okay. So what will happen is that they will make another coin, 0, whose value is 0, except that inside there is the definition of there is information that say, okay, it is OpenAsset, and this is, for example, 100 USD. So what you will see here is, for example, if the Fed wanted to emit 5 USD, you will see 5 in the op return. Okay. Up return. So up return is a special script sig. It's a special script pub key that have no matching script sig. Okay, you can't spend the up return. It's just a hack to push some information into the transaction, arbitrary information into the transaction. Okay. So on the OpenAsset protocol, in fact, you have what you have, technically speaking, inside the op return is something, let's say OA. Every op return of open asset starts with OA, and then, for example, if you want to emit 5 USD, it's 5. So for a traditional miner, traditional miner of Bitcoin are not aware that this transaction is a open asset transaction. Okay, for them it's just a valid transaction that spend a little bit. And I forgot something. The 100 coin that the Fed spends, they need to send it back to them, or they will lose money. So from the miner's point of view, this transaction is a normal transaction. There is no open asset. Every miner understands that, and there is no modification to the Bitcoin protocol. Okay, but for wallets that understand the open asset protocol, when they see that, they see, oh, okay, this means that this is 5 assets. The 5 here that you see here means that this is 5 assets. But which kind of asset? Is it USD? Is it something else? So in open asset, the identity of an asset is not its name. It is the hash of the script pub key of the Fed. So hash of script. Okay. If what? Is so it this is when in this case the Fed want to issue 5 USD to Alice. Okay, so what is going on is that this 5 here, okay, this 5 here means that this is 5 the first input. It's always, imagine that there was other thing here, we don't know. This 5 here means that the first input is an issuance. So the 5 came from here, and the ID of the asset is determined by the hash of the script pub key, so the hash of the identity of the Fed. Okay, we know that this coin can only be emitted by the Fed because the Fed is the only one which can spend this coin. Okay, so this is how you can identify the issuer. Okay. So is it good for the issuance? Okay. So for the issuance, I will say it's a hard part. The easy part is transfer, because once you have issuing, for example, imagine that Alice want to send to Bob. What will happen is the following things. So this 5 also, it means that the first one is an issuance of 5 USD, and also it's in order, so it's the first 5, so this is the coin that is 5 USD. Okay? The 5 is referred to the first input, and then it's for example, if I got 5 and 6, for example, it will be 5 USD, 6, because you can have multiple number here. It will be 5 USD here and 6 USD for the second coin. Okay, but Here I take the simple fact 5. So we emit that and we send it to this. So this coin now from the miner's perspective, it is only a fraction of Bitcoin, but from the open asset wallet perspective, it is 5 USD. Okay. So now for the transfer, so for the transfer, it's kind of easy also. So imagine that now Alice wants to send 2 USD to Bob. Okay, let's take a simple example. So we have, like always, a transaction. So if Alice wants to send this USD, what she will say, she will spend the 5 USD here. So here you have 5 USD. Okay. Then what will happen is that she will send 2 USD to Bob and 3 USD back to herself. Okay. So how does it works with the open asset protocol? By the way, I just made a mistake. The op return, in this case, it's at the end. You will see why the ordering changed. I will just fix that. The same. I just copy that again. OA5. Okay. Okay. So the issuance, you will see why it matters, but it's just that the op return should be at the end for the issuance. So on the protocol aspect, here we have so 2 USD to Bob and 3 USD to Alice. Okay. And for the op return, what happened is that you have the op return, so the 0 op, and the data of the op return has this following format. It's OA 2 3. So 2 3. So what it takes the 2 first of USD, okay, and assign it to the first output, and then it takes the 3 next one of USD and then assign that to the second output. Okay, so that's it. We have done all operation that we need for open assets. So it's kind of a simple protocol. Imagine that, for example, you have, another coin here, for example, 10 euro. Okay, for whatever reason. If you want to add some output, then you have spent your 5 USD already. So you can say, for example, after I want to spend for the next output that will be here, I want to spend 10, and then you go to the next one and assign it to the last output. Okay, it's an ordering based. So we'll keep it simple for now. Okay. So that's it. So where do contracts fit into that? In fact, it's really simple. If, for example, if I show you, CoinPrism. So CoinPrism is a website where you can create your own wallet in Colorado Coin. You can issue coins very easily. and you can explore a little bit the transaction. Okay, so if I check open assets, you will see that. So I will take an asset that exists here, asset. Okay, so there is lots of kind of assets, Okay, I will take coder wall, whatever. So you will see that there is lots of different information about an asset. You see there is a nice picture, for example, of the asset here. You see there is some. You see that the divisibility is indivisible. In fact, the divisibility is for the user interface. For example, the divisibility of USD is 2 because the smallest number of USD you can have is 0.01. Divisibility is 2. And can I show the code? So yeah, so there is some kind of information, and where does this information fit? This information fits into what we call an asset definition URL. So I will show that. Oh no. This one doesn't work. I will take another. I will take another asset that has a definition file. But what happened is that during the issuance, in the op return, you can also fit an address, http / whatever. Okay, and this address point to what we call the asset definition file will give more information about the coin. Okay, for example, what is the nice display name, what is the picture of the coin, what is the divisibility, stuff that matters to wallets to present information wisely. So oh, that's fine. Yeah. So for example, I'd like to show you what is a typical asset definition file. Okay, this one will work. One. So this is a simple JSON file where you will see the information once it's no way. Wait. The link is dead. Sorry? Okay. So this is the typical structure of an asset definition file. What things you can find on it is, for example, the divisibility. So the divisibility only matters for visual presentation to the user. Okay. For example, if you are emitting USD, on the protocol aspect, for example, if you want to emit $1, it will be 100. But if you have a divisibility of 2, it means that the wallets will present it as 1,00. Okay, so this is the divisibility here. What do we have interesting? We have the image URL, icon URL. So this kind of information are nice for correct coin wallets to show a nice picture of the coin. The description, whatever. And also what we call the contract URL. So the contract URL is, for example, a human readable contract that is attached to the asset in question. So you have all kind of information about your coin. What you need to know is that this format also is extensible. Okay, you can easily change the format without any problem, and make your own asset definition file. So, for example, imagine that instead of So instead, for example, instead of emitting a currency, imagine that you want to emit shares of company. Okay, we can very well imagine, or maybe a voting token. It will be easier to explain. We can very easily imagine a JSON file that has the following aspects. By the way, is it good about issuing and transfer? Okay.
Yeah, OA2 is OA2.
What?
Yeah, the input and output is not much.
The coins, the color. Yeah, good question. If the output and input doesn't match, it is an invalid color coin transaction, and what it means is the coins are destroyed.
Destroy.
Yes. So, that destroy is very radical, you know. Yeah. So it's why I didn't show you, but OpenAsset have their own scheme of address. So basically, Colored Coin enabled wallets won't agree to send to a normal wallet, because the normal wallet who doesn't know anything about Colored Coin can destroy the assets. So that's why if you want to transmit assets, you can't use a regular Bitcoin application. You need a wallet that understands the protocol. So the way we do that is by having another scheme for the address. Okay. So yes. It was a problem at the beginning, but now that we have another address, the correct coin wallet just refused to send to a classic address. They refuse to send asset to classical address. So yeah, I was saying, imagine that you want to emit some voting coin. So we can imagine, for example, that you are the municipality of your city, okay, and then there is some kind of election about which mayor will be elected, okay, for your city. So what you can have inside the asset definition file is the following thing. It is a type. We can invent a type, for example, voting. Okay? And we can say, if you want to vote for example, Bill Gates as a mayor of your city, I don't know. So you can say the same thing, candidates, we can imagine it, okay? Candidates, 2 points, and we will have an array. Not easy to code on a whiteboard, but do it. We will say name, I don't know, Bill Gates, Bill, and name and address, ABC, and then if there is another candidate, I don't know, for example, Hillary, address. So it's not written in Japanese, okay, it's Romaji, but I'm not used to write so much these days. Okay, so we can imagine in the asset definition file that the token is a voting token, and then you have 2 candidates. One is Bill, the other is Hillary, and if you want to vote for one or the other, you can just send the money to a particular, send the token to the particular address. Okay, so what it means is that despite the simplicity of the open asset protocol, it is very extensible thanks to this asset definition file. Then, surely enough, we need to code software that understands, for example, this particular format of the asset definition file. But in theory, it is possible. Okay. So in this case, since the coins are sent to a particular address, it is easy afterward to just check what candidate is winning. But imagine that we add a new rule. For example, we want to add the rule that someone can't transfer his vote to someone else. Okay? So for example, we don't want that. For example, if there is the city, okay, send the voting coin to Alice, and we don't want that Alice send to Bob, and then Bob can vote. We want to prevent transferability of the coin. We can see that since everything happened on the blockchain, this kind of behavior can be automatically detected. Okay, so in a sense, it's not entirely a smart contract, but in a sense, it is very easy for a software to verify programmatically the rules that it reads inside the asset definition file, and then to apply them to verify that, for example, if there is not a non-transferability of the vote, that this is prohibited. Yes?
Would it be that you transfer?
Yes, if you want, yeah, it's an example. It's an example. Yes, if you want a rule where they can transfer the vote, then you can, yeah. But I wanted to show you an example a little bit more complicated where you don't want they transfer it. So it is possible to do quite complicated rule, okay, because you can see the blockchain and what is happening. And for example, you can push it on in other topic. For example, shares of a company. Imagine that a company want to commit itself to give 5% of dividends per year. Imagine that. And that the company, all its revenue come on one particular Bitcoin address. Then at the end of the year, you can have a software that verify that they respect the contract to the shareholder. Okay? So sure, they can not respect it if they want. But we will see that there is some kind of ways to push them to respect their contract. And what is important is that, as always, software can detect the violation of the contract. So we'll see that this asset definition file is interesting because also this is a very easy to parse format, but you can also add, like you have seen, a contract URL that is more human readable, okay, where people that for example, a PDF file that explains how what work in human form, but you have also the computer form that permits some software to enforce and to detect violation of contract. Is it good? Okay. So now the last question is what about Ricardian contract and all of that. So you understood the principle of how we can kind of detect violation of contract, But the last thing I didn't show you is imagine that you have a malicious issuer. Basically, right now, by doing that, it can, in theory, change the asset definition file when he wants. You remember this asset definition file? It's an address that points to it, and this address most likely is owned by the issuer. And if you want the issuer to not change the contract afterward, you have to take additional step. Okay? So I will explain what those steps are, okay, to prevent this. Like I said, it's very theoretical. Okay, nobody implements it yet, but just to show you that it is possible to say, okay, this coin have this contract attached and nobody can change it. Okay? So the principle is very easy. So you remember for issuing, so for example, you have 100 Bitcoin with at the Fed. Then the Fed, for issuing it, they spend it. Okay, and then they send, for example, 0.001 to Alice. The rest to the Fed. Okay. And like I showed you before, there is a op return here, and the data inside the op return is something like OA. So if you want to send 5 to Alice, it's 5. Okay, remember that? And I said that the asset definition file, the address of the asset definition file can be found here. Okay. So what I want to do is to be sure that the creator of this contract do not change the contract afterward. I want to lock down the contract, and it is important because imagine that you have a conflict between the issuer and the holder of the coin. Then you can turn on an arbiter, and the arbiter can be sure that the contract is how it is. So the only difference is this one. You remember the Fed has his own script key, script key, sorry. Okay. And how to prevent any change is by including a hash of the contract inside the script key. So how it works is that if you know the scripting language of Bitcoin, you can say that you have the hash, for example, 0.DA5, whatever, updrop. Okay, and then the rest of the condition for issuing. In fact, this push some data into the stack and just drop the data. So it has no impact. I mean, on the script, it does nothing. But you remember that the coin is described by the hash of the script public key. So if someone, whoever owns the coin, can see which script pub key emitted it, he can get the hash, okay, and then he can verify that the contract to this address satisfy the hash here. Okay, so that's how you can lock down That's so there is some kind of attack where someone can emit his own coin, use the same hash, and then use it with his own script key. I don't want to enter in the details, but very easily you can just embed the second part of the script inside the contract, so you are sure that nobody is trying to emit a coin with your contract. Okay? So by doing that, like I said, so you can have whatever the correct coin can be whatever you want, company shares, voting token, whatever. They can have a contract attached. You can verify valuation automatically, and more importantly, you can prove that the contract was not altered by the issuer. And also, a nice thing is that the contract can be kept private. For example, here I have published it on the blockchain, but we can very well imagine that the contract, the asset definition file is sent out of band to the holder of the coin, and then the holder of the coin just check if the hash corresponds to this hash. Okay? So this is all there is about Ricardian contract we know. It is human readable because inside the contract you have a link to a PDF which explains everything. It can be written by programs, and it is digitally signed and unspoofable and can't be tampered with. So this is the main thing. The last thing I wanted to, I forget what I wanted to talk before continuing. I wanted to talk about something. It will come back, I think. Whatever, it will come back to my mind later. So what I'd like to do right now, so I don't know how many of you have your computer and that can be ready to code. What I would like to do ideally, but I don't know your schedule about what you want to say about Ethereum afterward.
No, maybe it's we want to Ethereum. But
Okay, so we'll see what you want to work with, but what I would have proposed is that we try to issue real coins onto the blockchain by code and then transfer them between us. Yes? Hmm? The issuer can emit whatever number he wants. The issuer is the ultimate guardian about that. Okay, so there is no limit about how many he can emit. I mean, there is a technical limit. Yes.
The Bitcoin, because first of all, you're using Satoshi. There are 21 billion Bitcoin. Satoshis to Bitcoin. So first, we have a lot of Satoshis. Secondly, the Satoshis, I guess, don't die. The Satoshis are still moving around as Satoshis.
Yes.
As long as you don't lose your private key or something.
Yes.
So you can actually recycle this.
Yes. Your point was what happened if there is no Bitcoin left and you can't emit it anymore? Yeah, but if there is no Bitcoin left to transfer, then there is no Bitcoin at all. I mean,
but that will just accelerate the process.
But we don't.
Also,
we recycle it.
More as well. If we find that the 100 is too little, then we can make a change to Bitcoin that will
But I can also an interesting thing that I think you will argue that in I have one case where it involves the destruction of Bitcoin. I will speak about that. Here we talk about the Fed, okay? But the Fed, it's not funny because it's a reputable company. It's so imagine a world where the issuer is anonymous. Okay, so you don't know how to trust this guy that issues the coins. So what will happen is in such a, for example, imagine that a company entirely, I would say it would be only on the black market. So imagine a company that is entirely anonymous, and then you want to trust them with your money to fund their project, okay? But you have no legal recourse to enforce in case of violation of contract. So how can it work? Yeah, I think there will be some limitation, but imagine that you say, for example, I don't know, a Toto company. Okay. The way we deal with trust in anonymous environments is with what we call proof of burn. So the principle is that you establish an identity by burning Bitcoin. And by burning, it means making them disappear. And it's very easy, if, for example, if you want to do it, you spend, for example, 100 Bitcoin, okay? And then on the output, you spend 100 to up return. These coins are probably unspendable, and so the way it works is that Toto Corp can say, okay, I developed my brand, I burned Bitcoin to get started. So if you want to deal with Toto Corp, even if you don't know them, you know that they will not try to fraud you for more than 100 Bitcoin, because it will not be profitable for them to fraud you. For example, imagine that you have a 50 Bitcoin deal with them. If they violate their contract, then they trash their reputation, because they invested 100 Bitcoin into their reputation. If they violate the contract, then they lose it all. They might steal you 50 Bitcoin, but they lose 100, so they are not winning. Two? Yeah. So it depends on, it is possible. Yeah. When the asset circulates, you can always send it back to the issuer, and depending on what the contract specify, for example, banks are doing that. If in fact it's what my company is doing, Betaco, is that banks, for example, let's say HSBC, okay, HSBC might emit their own USD, okay, on the Bitcoin network, but in the contract they can specify that they have an obligation to convert this USD, a legal obligation to convert this USD into real cash if you go to their place, or maybe against Bitcoin from the rate of the day, for example. So if you want, so imagine that your five HSBC USD, you get that in your wallet, okay? Then you can, HSBC normally have the legal obligation to exchange the coin that they emitted and redeem you in whatever condition you want. But if you want to stay in the Bitcoin network, most likely they will exchange USD against Bitcoin at the rate of the day. It depends. Because what will happen when you want to redeem is that Alice will send 5 HSD USD to HSBC. Okay, then HSBC can decide, okay, I will keep the coin and then retransfer it to someone else, or most likely they will just destroy it. Okay, so it is their choice. For technical reason, I didn't go into that deeply, but for technical reason, it's better to destroy them. Yes, yes, but you can destroy the asset without destroying the underlying Satoshi. Okay, but you know, when I talk about the anonymous company Totocorp, proof of burn, in the proof of burn concept, the Satoshi are done forever. So this proof of burn might remove Bitcoin from the circulation way faster than just 600 Satoshi that was spent for. Yes, for what? Yes, yes. So the concept of proof of burn is that you really burn Bitcoin, and so it's a proof that you spend money to your identity. So it's yeah, but the proof of burn is has been first talked about in the Open Bazaar project that want to create a decentralized marketplace. So their principle is that participants, the seller and buyer, can burn Bitcoin to prove they're worthy. And so if you want to, like I said, if you want to deal, for example, for 10 Bitcoins with some merchants, if you see that they burned 100 Bitcoin, you know that they have no incentive to fraud you because they will lose their reputation doing so. Yes. Yeah. Yeah. Yes. Yeah. You can do it. You can do it. Yeah. You can do it. For example, a bond. It's a good question. A bond, the only thing you differ with is inside the asset definition file. You can imagine a definition of a bond. So you might have the maturity value, the yield, and stuff like that. And like since it is a Ricardian contract, you can prove by software that it is not violated. And yes, at the end of the maturity, they can just send it to the issuer, so the issuer can pay back the face value. What?
Would everybody redeem?
No.
Would you get back?
No.
In any case.
No. But there is a way. If you really want to get back your, but the principle of burning is really to prove that you put money at stake in your reputation. Okay. But if you really want a system where you can redeem the 100, you can very well imagine a notary that keep 100 in custody and then just release them on when the contract is finished. Yeah.
And also, the notary doesn't actually have to have money, right? Now, 3 different notaries, each have a key.
Yes.
And also, the original owner may have. So, notary can't see.
Yeah. So yes, so this whole Ricardian thing is just a way to promise thing on the blockchain and to have a proof of valuation if it happens. So if you have the proof of valuation, you can then hurt the reputation of the one that frauded you. So this is the concept behind it. It's very new, It's like I said, there is not application right now, but we can imagine stuff on that. Okay. So that's any question? No, that's clear. So from here, what do you want to do? So there's two things that we can do. Is we can try to code a little bit Corel coin and Bitcoin. If you have Mac or Linux, it will work. I work to make it work nicely. If you have Windows, it will work also. So in this case, we can code some stuff to transfer it. Or so I don't know what you have.
Yeah,
You
let's
prepare
develop.
now.
Yeah. Develop PowerPoint.
Okay, so I don't know how can we proceed. Do I show you how to do it in code, or do we just each one try to code it and I just try to help you into doing that? I don't know to we can organize that.
You can live coding.
If I do the coding.
Live coding.
Okay. I do the live coding. Okay. So here.
Thank you very much.
Oh, no.
It's very
See you. Thanks. So the code is very simple. So like I say, this code can work either on Mac, on Android, on iOS, on whatever. I work hard to make Bitcoin work on all platforms. So if you already know Visual Studio, in fact, you have to reference the package. So manage NuGet package reference. It's called Bitcoin. Okay. Sorry? It's C#. Yes. Yeah, you have so Mono Develop. If you code on Mac, it's free. And the Visual Studio, there is a Visual Studio Community Edition that you can also download for free. Yeah. Okay. So one of the problem is that I don't have any key with money on it. But I will show you the code, and then if someone can send me some dust coin, I will reimburse you. So we can do a real emission on the blockchain. Then we will do that. Yeah. Okay. But we don't need to be confirmed. In fact, we can run on unconf. It's okay. Wait, I will generate a new address. Okay, dot get address tech. Okay. Yes. So yes. So Bitcoin, the library I am using, I start working on it 1 year ago, and now it's the biggest library that exists on .NET. So if you want to code something on .NET related to Bitcoin, use Bitcoin. But I can send you the address. Yes. Thanks. Oh, no problem. So, okay. I sent you the address. I need to get back the keys. That's not a problem if the key appears. Anyway, there will not be a lot of money on that. To string. Okay. So Bitcoin secret equal my key. Okay. So let's say this is the key of Fed. So let's say this is the key of Fed. So you have time. I will code a little bit, so you have time. Don't worry about it for now. We will send it after that. So imagine I am the Fed. Okay. So first you remember the schema for issuing Bitcoin. I need to spend a coin that belongs to Fed. You remember? So imagine that the coin, the outpoint object represents the address of a coin. Okay, you uniquely identify a coin, the output. So imagine that we have the output point here, for example 3, or so it's an issuance outpoint. So can I compile? No. Okay. So I have an issuance outpoint. So when I will get some money on that, I will just reference the outpoint of the coin I want to spend for issuing something. And the way to do it easily in Bitcoin is to use the transaction builder. And what I need to do to transfer, you will see it's very simple. I do transaction builder dot add keys, so the private keys for signing the transactions, dot issue assets. So the destination. So imagine that we have Alice, Bitcoin secret. We'll replace it later, so we create a key for Alice. We'll replace it later, okay? So if the Fed want to issue to Alice, dot get address, they can just do it that way. I can make the code easier. Alice Fed asset. So the assets, I need to tell which asset and how much I want to emit. So I want to emit the Fed asset, and I want to emit, I don't know, for example, 1,000. Okay? Once I've done that, you remember you always need Fed will spend some coins to emit something. So to emit the asset, so you need to get back the coins. So set changes to the Fed. Okay. And also I need to give some fees to the miners, so my transaction get confirmed. So send fees. So I can say, I don't know, I want Satoshi 0.00. I think nowadays it's more around that, right? Or I can be better, I can say send estimated fees. So it will calculate automatically the the right things. And once I've done that, I just have to build the transaction to say that I want to sign it. And I have my transaction. But here I need a real number here. So let's wait. I will generate a random number. Get byte T2. Okay, so just to show you how the transaction looks like. Runtime. What the system dot numeric dot big integer. Okay. So I run it. No issuance coin. I forgot. You see, I say that I want to see, I want to sign with the Fed keys. I want to emit to Alice, but I didn't say which coin I want to spend to emit the asset. So this is what I need to add. Add coins. So it's called an issuance coin, and it only asks so the address of the previous of the coin I want to spend. So it's a issuance coin, issuance outpoint, and the transaction output. So the transaction output is the value and the script pub key. But in fact, the value we don't need it. We don't really need it. So we don't care about the value, but it will be the destination. We know that the issuance coin script pub key will be the Fed. Okay. So that's all. If I run that, not even enough phone. Yeah. So I run it, but they are saying to me that I have not enough phone to create the transaction. Why is that? It's very simple. It's because for sending the change, for doing this transaction, I need to send fees. You know, here. And so if the output I am spending have no money, then we can't get Bitcoin to fund the transaction to the miners. So we'll see, for example, if there was money.satoshi, we'd say 1 Bitcoin. Change address should be specified uncolored. Oh yeah, I know why. This I will need to fix. Okay, pass now. So I'd like to show the transaction to string. Maybe I can zoom a little bit. So now we can see the transaction that has been done, that follows the Open Asset Protocol for issuing Fed coins. So you can see that in the input, I am spending some coin. The signature, the script sig is here, okay? And the up return, the up return is, like I said, at the end, okay? So the format of the up return, like I said, it's mostly yes, it's encoded into a particular way, but it's only OA and I don't know how much I have emitted. I think 100. So this basically means only Open Asset Protocol 1000, excuse me. And so the two outputs are this output, you see, it's 600 Satoshi. So this one is mostly the Colorado transaction output. And the second output is the change. Okay? Because Bitcoin, I needed to spend some money to make this transaction. So I need to get it back. Okay? So I think we are done on the code on how to emit it. I just want to show you the transfer because the transfer is also very simple. It's approximately the same. So you see how how Fed send coins to Alice. But imagine that you have Bob. Okay. So imagine that you have Bob, and then Alice wants to send asset to Bob. So the way she does that is, so she use transaction builder dot add keys. Who will sign? It's Alice. Add coin. Send assets to who? Bob. What kind of assets? So the Fed. And the quantity will be, I don't know, for example, she wants to set 100. Okay. So set change. She wants the change to go back to her. So then we'll send the fees. And we will build the transactions. I forgot the coin that I want to spend. Okay. So the coin I want to spend is the previous coin. So it's a colored coin. Normally you have some API that permit you to get this colored coin very easily. I've done one of these API that is called Qubit Ninja, and in fact I have a Nugget package where you can just query on the service and it get back to you the real colored coin that you can easily use on this program. But the colored coin I want to spend, it came from the previous transaction, the previous one, okay? And what does it need? Colored entry. Oh no, I have better way. The previous colored coin, I need to give in some information, but so it is a fake coin. The amount, the previous one, the amount is 1,000. In fact, it's this one. It's the top one. Wait, it's that. Okay, it's the same. And what is the coin that bear it? So the coin that bear it is the transaction dot output. I try to do it the simplest way I can. Transaction dot output. I think it was the first one, the correct coin. I will review that because it sounds like complicated like that, but it's not really. Here. So if I run that, not even enough phone. Yeah, I have the same problem as before, you know. Alice don't have enough fund to fund this transaction because she need to pay the miners. So I will just add a fake coin. I will add a fake coin that belongs to which one is the best? But Alice don't have a previous coin. Right. I create a random one so it pass. Okay. You takes out. So it's money.coins. Imagine that's. I will comment that because it sounds like complicated, but it's really not. Arguments. New out points. We'll make it 5. Now it pass normally. Get by it's 32. I come back to that. But now if I send, okay, it doesn't crash. The transaction I've built is, I didn't get it. Bob, no, Alice to Bob, I will call it. So Alice to Bob, dot to string, just that we can see the transaction. Okay. So basically what we can see in this transaction is that two coins are being spent, and there is the colored coin that is being spent because Alice wants to send money to Bob, and there is also a normal coin that is being spent to fund the transaction. Okay, and in the output, you see two interesting things. You see that the 600 Satoshi that you can see here and here, there is fake coin that are sent to Bob, and the change which is sent to Alice back. You can see the money that Alice spent to fund the transaction get back to her, and that's it. You see the op return here of open assets, and so this is a valid transaction of open asset that send coin from one another. So basically, the only part of the code that is kind of complicated is the one where I add the coins informations, but really all this information here, for identifying a correct coin, you just have two kind of information. You have the asset money, so which kind of coin it is and how many there is, and so the coin information is basically only the transaction output with the address of it. Okay, so basically, if you remember my schema on the keyboard, just to give all the information related to the correct coin we are spending. That's all. So this code, I think this code can be kind of easier to understand if you take a look at my book, because I've written a book that is called Blockchain Programming in C#, and I explain how to code correct coin more easily. In fact, there is some helper class that get away a lot of the stuff I've done by hand here. But basically, the code it's almost simple. You don't have to mess very low level with the transaction. So I think that's a good thing. And so that's it. That's all I wanted to show you. And I push you to, if you are interested into the correct coin, one more time to check my book. My book, don't go deep inside the details. It's free, okay? It only stay at the conceptual level and how to get stuff done in code. That's it. So thanks for listening, and so maybe you will try to do it yourself. Thanks. So yeah. So, any question? Yeah.
If we make the contact URL, add contact URL on the operator, the contact URL is hash to the split pub key. And then I show the contact. You points out the contact URL, but however the contact URL itself will be changed by the issuer, by the modify. The issuer can change as a definition, on the domain owner.
Yes.
How to prevent it that?
Your question, if I understand, is that how to prevent the issuer to change the contract on the address.
Yeah.
So you can't prevent him to change the contract, but if you implement Ricardian contract and you embed the hash of the contract into the script pub key of the coin you are emitting, then in this case you can change it, but you have proof that it changed because you have the hash of the real contract into the definition of your asset ID. Mm-hmm. So this is why Ricardian contract help that if it changed, you will have the proof, and sure, it can bring down the link, but you can very well imagine some wallets that just download the contract offline. So if the issuer try to shut down their service, you don't care because you have a copy and then you can prove it. Okay.
Then HTTP is okay. Like
HTTP is okay, yeah, because you verify it. But you can use HTTPS if you want, but I don't. There is one kind of there is a benefit of using HTTPS though. Is imagine that you want to be sure that it is the Fed that is issuing the correct coin. You will want that the asset definition file to be on fed.org on HTTPS. So you have the cryptographic proof that you are speaking with the real Fed. So yeah, you can do that.
So every user for the services, some Ricardian contract services users should download the contract URL at first.
Yes, and I think they should keep it in cache then to prevent the issuer to shut down the service.
Oh, then like in the open browser case, download it and then upload again by myself or who will revive the service.
You?
Yeah, I can revive the service by the contract I downloaded, or the issuer shut down the service suddenly, or the maliciously change, and then other people don't prove it.
Yes, and you can republish it. Is this what you were saying?
So I mean contract. How to prove the contract? This is
this is very easy to prove it is the real one. You just hash it, and you compare it to the
contract itself. Yeah.
Yes.
So this is the hash and then into public key.
Yes.
Because previous is a URL only hash to it.
The URL.
That is not safe, right?
Yes, I was saying that it's good to be on HTTPS because you will have proof that it's a Fed. But yes, you are right. If the service shut down, then you don't have any proof that it came from https://fed.org. That's what you mean. But if Fed, for example, is issuing his own currency, you expect it to somewhere on their website that they make a reference to their asset ID. So this is an out-of-band insurance of that. And in the case, for example, of anonymous company that's burnt money for their identity, they can tie their identity inside the contracts. So then someone that has the contract might prove that such identity signed it with his private key. So
is these things already formatted in somewhere? How to prove the definition, the Ricardian contract definition, the definition.
So the definition of
Ricardian contract,
the Ricardian contract is defined. Is defined in the open asset specification. By the way, I contributed to it. But currently it's not really implemented. It's open, and maybe since it is a JSON file, maybe some people will find better way of doing it when they will try to implement it. I don't know, but yes, for now it's specified into the open asset protocol. But it is flexible, it's the asset definition file is just a JSON, so you can do your own way of doing it.
After that, please share the how to define the asset definition, and then how to send the asset definition to the is it on the book, the asset definition, how to issue a proof. So my color coin definition is here.
So the asset definition, you can, since it is just a JSON file, you can emit it where you want. Okay, you don't have to emit. If you for example, if you use CoinPrism is a correct coin wallet, you can emit your own coin yourself, and they host the JSON file on their own server. Okay, so it's more easy. But I mean, you can publish it where you want after. And but the only thing is that in code, if you want to point to the address of the contact, I can show you very quickly. But it's like I said, when you emit, when you issue the coin, in fact, you have another property that is called definition URL here, and then you can say mycompany.org/contract, for example. Okay. Yeah, it's a URL. So okay. If you do that, you will see that this definition URL is embedded directly into the up return. So that's you host it when you want, and when you issue it, you publish it through the issuance coin. So I recall the issuance coin is the coin that you spend when you want to issue some assets. Okay.
The issuer can prove this is my coin's definition. However, issuer can also change the URL, the inside of the URL.
Yes, but if you mean the issuer can change?
I can change the contract. I can change the. I have the mycompany.org contract domain.
Yes.
And then I can change what is inside of it. Yeah, what is added.
They can't really change it because this data is published on the blockchain, right? So, but if they emit, for example, they do another emission and then they change the definition URL, yes, they can change it. And I think it's in some point better, because imagine that for one reason or another, Toto.org loses domain, at least it can change it. But what is important is that the contracts refer to the coin, and so refer to the asset ID. And so if the asset ID has the hash of the contract, then you are safe.
It means the contract hash is the URL hash or the more.
The contract hash is the JSON one. The JSON one.
JSON one only.
Yes, JSON only. If there is a human readable contract, then in the asset definition file, so you have the contract URL, but you have also another field that is called contract hash. So, for example, if you have a contract human readable at the contract URL, you hash that and you include the hash inside the contract hash field, and then you hash the whole JSON file. So you have a hash that represents all data related to your coin.
Oh, yeah. I read the regarding contracts documents on the web. There's some information about the like XML or the other things, the many formats. So it's already is only on the JSON. The definition is only JSON.
Yes.
Oh.
Yes.
When defined it? When defined it, asset definition, asset definition is only JSON format. Not other format is.
It's only it's only JSON.
Impossible to write other formats.
Well, it's it is possible.
But
I mean, yes. I mean the asset definition file right now it's on JSON, but this is. I mean, it's two different specifications of correct coin. You know, the Open Asset Protocol, the core of Open Asset Protocol is what I show you when I show you at the transaction level how it looks like. But it's true that if, for example, there is some need one day to have another format for the asset definition file, in theory, someone can make his own. There's no problem to that. And the most important thing is that lots of software support it. So, for example, if you use the asset definition file in JSON, right now there is lots of fields that are understood by Coin Prism and other correct coin wallets.
Oh, yeah.
The asset definition file, since you're hashing that, what I wonder is, since a JSON file can have spaces in it, will it be a compressed JSON file, or
We don't know the the thing is that the normal thing to do is we don't normalize it.
Uh-huh.
So it means that you query this address, you get back a set of bytes from the content of the HTTP, and then you just hash it. That's all. We don't normalize it
Okay. All right.
because normalizing JSON is a tough problem with lots of potential problem issue. Meanwhile, just taking the byte and hashing them, it's very simple to do.
So there is like a contract malleability, something like that.
Well, there is contract malleability if you don't include the hash of the contract into the script key. Yeah. But if you do, that's okay. If you have the hash of the contract into the script key, then they can't do it.
They can do it.
They can't. Okay. Good. Good. Other question? No, that's fine.
It's not a question, but we went to the event on this Monday.
Yeah.
And there were some talks about side chains or stuff
Yes.
like that. So, do you have anything to say about that?
So sidechain compared to Ricardian are very different topic. Sidechain is when you want to create a new cryptocurrency that work on other rules. Okay, but the problem with sidechain is that you so I don't know deeply technically of sidechain work right now, but the problem I understood is that you need to convince miners to mine your sidechain. So if you have a small company, you can't try to push the miners to mine your coin because for them it's worthless. They won't do it. Meanwhile, if you just emit Corride coin, you don't have any permission to ask to anybody to do it. Okay, Corride coin is chain side chain is really if you want to experiment new rules on a cryptocurrency. So I might say, for example, if you want to have a cryptocurrency that have 10-second blocks, for in the Bitcoin network it's 10 minutes. If you want to experiment with one with 10 seconds, then you can. Okay, you create your own ad chain and do your stuff. You can experiment, like for example, a blockchain that does not leak any any trail, so nobody can follow the path of the transactions. We can imagine lots of stuff, but it is very different of Corride coin. Corride coin is just an issuer that want to issue some token that represents something, and then you don't need to ask for any authorization, or you don't have to convince anybody to mine this coin.
I read an article on internet that I sent a link. I don't understand what it says, but maybe you will understand the question. It says that colored coins are incompatible with Bitcoin's simplified payment verification (SPV).
Yes.
And apparently that's the guy who writes that is the guy who is an advocate of sidechain and says something important. So can you explain?
Yes. This is a good point. Corride coin are not compatible with SPV. So what it means basically, it means that, for example, you have seen Aaron was in last week. Okay, so he made an SPV wallet. It means that it's a wallet that does not depend on any server. It can just ask to the network what transaction belong to him. So what it means when we say Corride coin does not support SPV wallet, it means that if you want to create your own SPV wallet, you need to rely on a server that index the whole blockchain. So you need to have a trust dependency between your mobile device and the service that provide correct coin informations. So if you want to protect against a malicious block explorer, what you can do is to cross-check the result. For example, if you have a coin prism that has its own block explorer, but you can cross-check, for example, with mine that is called Qubit Ninja, and you can cross-check across several blockchain so your client is sure that if the blockchain say he owns coins, he really owns it. Theoretically, you can prove cryptographically speaking that your address owns a coin at a certain block. You can do it, but the problem is that in correct coin, the size of the proof gets bigger and bigger with time, and it's a technical problem that nobody has solved yet. Some implementation of correct coin like IPO-BC, I think it's called IPO-BC. They try to fix the at least make the problem a little less expensive, but they did not fix it entirely. So basically, it means that currently, if you want wallets, you can't have only a software on your mobile phone that just listens to the network. Become network, it will not be enough. So yeah, that certainly is a problem, but for now there is no solution to that. Maybe we'll find. I like to find one day, but right now we don't have any solution to make it work. Yes. Yeah.
How do you? Yeah, what is it? Other
what is the advantage to use correct coin than sidechain? I guess if you want to, if you do your small company and you want to emit shares of your company, you don't have to market the miners to mine your coin. Just do it on the blockchain. If you want to use a sidechain for emitting your share of your company, it means that people, if they want to trade it, they will need to download the software that understands your new coin. You will need to convince miners to mine your sidechain. So it's not really feasible. It's not sidechain and correct coin are not for the same purpose. Okay. Sidechain is to create a new cryptocurrency. Correct coin is not a new cryptocurrency, it's just Bitcoin. So that's basically it. If you want to create a new cryptocurrency, you need to market it to miners. You need to market it to people that will download your software and make run your nodes. It's a whole kind of different problem. It's not just a small company that emits some token. It's very low, heavy weight. The sidechain is, you're right, the sidechain is another blockchain, basically. Okay. The only difference, the innovation is that you can freeze Bitcoin on the blockchain and emit currency on the other side of the chain. And then you can do the reverse, unfreeze the Bitcoin and freeze on the sidechain. So the great advance of sidechain is to be able to pass from one currency to another and back and forth. So if, for example, for governments try to track transaction too much, what will happen is that a new sidechain will appear and people will just jump on the other one. And once the government stop doing it, they will come back Bitcoin. They can change cryptocurrency as they like. So it's a way to bring diversity in the cryptocurrency space while leveraging the Bitcoin the current Bitcoin ecosystem. So merge mining, I don't remember well the disadvantage. I've already seen that, but one of the problems of merge mining is that you still need to, but I think it's like sidechain anyway. You need to convince miners to mine your crypto. But I think that I don't remember. There was another disadvantage, but I don't remember right now. Merge mining.
The penetration is a side to use the side chain or to use the card for use
Yes,
I
yes,
guess,
but by using a CorrectCoin wallet, you have access to a whole ecosystem of coins. You know, for example, if HSBC emits some USD, the Fed, the ECB emits some euro, you will have the same wallet to get both assets. Okay, as opposed as if each one make their own sidechain, you will have one wallet for the Fed coin and one wallet for the ECB coin. By using CorrectCoin wallet, then you can just get it into your own wallet. Okay? So that's basically what we do with Metaco right now, is that people will be able to store inside their private key. They will be able to store gold, euro or USD, and these assets are emitted by real banks that are trustable. Okay, so that's what we want to see, and everything use the same wallets. So if you have a wallet on a CoinPrism, then you can just withdraw your asset and put it on CoinPrism. You can do it whatever wallet you want.
But one thing about the USB, the different banks the assets is a different USD, right?
Yes.
Yeah. So if the banks is tied together to use the same assets, they need to make a multi-sig.
Now, if they want to use the same assets, then it means that the central banks to emit CorrectCoin. Because right now it's right now what happened in the current banking system is that you have your bank, I have my bank, but behind the scene, the euro I own in my banks are not real euro. It's euro emitted by my bank, and you have euro emitted by your bank. And most of the time, the system there is a settlement system that can convert one to another very simply. But if there is a bank crisis, like what we see in Greece, suddenly your euro in a Greece bank account can be converted into a euro in my bank to me. So the banking system has the same problem. But if you want the real USD, then you need to convince the Fed to emit the Fed coin as CorrectCoin. And this will be real USD. But right now, if you want real USD, you have two choices. Either you have real cash, a real dollar bill, or you are a bank and have an account on in the Fed bank. But only the banking system has right to that. So as an individual, you need real cash if you want to own real USD. So we have the same problem with CorrectCoin. It's the same concept. Only that it will be more apparent to the user. Meanwhile, right now, our banking system try to hide the complexity of it. So, yeah.
Yeah, maybe the protocol integration is a problem. Protocol integration. How do you think about the protocol? It's already defined. They're almost all defined. What is left should be defined more specifically? like a contract, yeah, and malleability or these kind of things. It should be more
Well, I don't.
defined. Yeah.
You mean what I would like to see on?
I mean some of the different specification people can
Yes.
make on the Bitcoin.
The
as
different
like,
protocol, you mean?
yeah, like a color coin, like a color coin, many definition. Open access protocol as any as a counterparty protocols or the
Yes.
yeah. So the open access protocol itself is specifically defined and then going to implement it on the like coin prism and yeah. So there's no malleability like that. Yeah, I mean,
you mean okay? It's what you mean.
Change
You mean is what you mean by integration between the protocol?
Yeah,
I
yes.
think we are not yet at this stage because we don't have the problem yet. There is two cases that can happen. Maybe one for one protocol will win all. It's possible. If it does not happen, I think that, for example, counterparty will be, for example, very successful for voting, maybe, and open asset will be very successful for shares. And I think they will address different market segments. I don't know where it will go. Right now, we have lots of different protocols that try, and as you see, with time, it will just converge at one place. And either there will be 5 protocols doing different things, or only one will win. We don't know yet. Right now, I don't think the developer community try to integrate one.
Yeah, thank you.
I think you had a question.
So to simplify, colored coin is just it's a form of message passing using the blockchain as validation.
Yeah.
And my next question. No, that's it. That's it. Thanks.
So your question is, Ricardian is just message passing on the blockchain?
Yeah, it uses blockchain for the signing and validation of the
Yes.
history.
Yes.
And so the message could be anything. It could be an email, or it could be keys to unlock bitcoins, or it could be a redemption code for the bank to.
Well, the correct coin most likely represents assets.
Mhm.
The asset can be whatever you can imagine.
Yeah.
But there is always this trust relationship that when you own an asset, you have
Mhm.
always a trust relationship with the issuer. Okay, after that it can be anything. A correct coin can be anything.
And do you see colored coins one day adding smart contract functionality to Bitcoin? Because it sounds like the asset could be a hook for a smart contract system, and that can be added to the Bitcoin blockchain without changing it.
If we want, for example, I show how to get some basic program that sees a violation, but I think one thing with the correct coin protocol that we won't be able to solve is this trust relationship that must exist between the issuer and the receiver.
Mm-hmm.
I think that's the most important. I think even if we have a smart contract, it will be hard to remove this trust relationship.
Sure.
So I don't know, maybe we'll find more complicated contracts. Maybe Bitcoin in some, I think some developers are starting to develop, but I'm not sure about that, but they are starting to try to develop a script version 2 of Bitcoin. And maybe it will permit better new usage. Right now, I don't know. So it's the premise of this technology. So very early, as industry mature, we'll see better.
Thank you.
Add something to that.
Yeah.
What you could do, I guess, is that you could use something like Codius or one of these kind of Oracle-based smart contract platforms. They would work fine, I guess, with with colored coins. So you could make you could have your Oracle, your Codius network or whatever it is, are going to sign a transaction if certain conditions in your contract are fulfilled, and you can make that a transaction that transfers colored coin assets. So if you did that, you've got some kind of trust outside of the network, but that trust can be distributed among a lot of different oracles. All that stuff you can do with Bitcoin right now, and you could also do with colored coins in just the same way.
And I think the nice thing about open assets is that since it follows the Bitcoin rules, what applies to Bitcoin applies to colored coin. So I have not thought, but if you have some set of oracle, then yes, you can have at least some. It's not Ethereum. Okay, Ethereum will go very very much deeply into that, but some kind of oracle, But it's so we can imagine, for example, a contract that become violated if 5 oracle agrees that it was violated. For example, we can do that kind of stuff. We can, for example, imagine, for example, an option. So I'm not very an option, for example, if at a certain rate the contract might be closed, need to be liquidated. So we can imagine, for example, some oracle that observe outside data and then sign when some condition into the outside world happen. And then if 3 of them sign, then it means that, for example, the contract is finished or something like that. We can imagine stuff like that. But it's very the beginning.
Is it possible to do atomic swaps of different colored coin assets?
Yes. Just technically speaking, it's exactly what we are. Yeah, it's a good point because I think a counterparty can do it. So basically, what happens if you want to do a swap is that you have. So you have, for example, USD 5, okay, and I don't know. You have 10 euro, for example. If you want to send, 2 USD and 5 euro to someone, then what will happen? For example, you want to send. So the transaction will be like that. It will be so 2 for example 2 to Bob. So 3 to Alice. And then if you want to send 2 euro, it will be 2 to Bob and 8 Alice. And the up return. So the up return should be here, but the up return should be here. Like that. So the up will be, in this case, it will be, so 2, 3, will be 2, 3. So we consume the 5, and then 2, 8. So these coins can come from different address, right? So it can be swapped this way. So yes, you can do a swap atomically. Whatever. So yeah, you can. Okay. So yeah, the strength of open asset protocol is very simple to explain you. So, say for example, here it's a simple transaction. I told you easily what is inside the operator, and it's still extensible thanks to the asset definition file. So that's why it's interesting. yeah, all this, the correct coin are already implemented. It's what Nasdaq is working on, and if you want to experiment with it, try Coin Prism. So Coin Prism. So this is a correct coin wallet that is done by the creator of this specification. It's called Flavien Charlon. Made a very good job on making a secure correct coin wallet. So yeah, it's I think more and more wallet will come for that. Okay. No question? Good? Okay, fine. ありがとうございます。